Greetings. This is the first part in a series of trainings that we're doing for Land O'Lakes and Melrose, Minnesota. Today's topic is just an introduction to the control panels and HMIs. And again, this is an introduction and overview of basic concepts of how our system is designed. What you're looking at here is this is a panel for boiler 1. We haven't energized this. Just as a point of reference, we're in the process of firing up the system now, so not everything is up and running, but we wanted to at least provide a good introduction to how things work. This is boiler 1. We've got two other panels here. You'll see one in action in just a second, but this is our control panel for boiler 1, and this is referred to as an HMI. HMI stands for Human Machine Interface, and it is a device that displays information to an operator and allows that operator to push buttons or switch things to control the plant. Here we have the emergency stop button. This kills the fuel train for boilers 1 and 2 in the case of an emergency. This is the same e-stop that is located by each exit door. And I wanted to start here just to give kind of a basic understanding of how these systems come together and throw some terminology at you that you may not have heard yet. Land O'Lakes Melrose uses a kind of a standard for their HMIs. This actual monitor is manufactured by Hope Industrial, and really all it is just a touchscreen monitor that uses a VGA connection for the video, and it uses a USB connection for the actual touch portion, and it does connect to an Arista, which is just a brand name of an industrial computer. So this Arista hooks up to the Land O'Lakes network via Ethernet, and the Arista has software on it called Thin Manager. And Thin Manager is a software application owned by Rockwell Automation or Allen Bradley. We'll talk a bit more about that. And Thin Manager works on a client-server basis where the Thin Manager has an IP address, and each Arista's IP address is on a sticker at each panel. When the Arista boots up, it has a very simple operating system that says, hey, I'm a Thin client, where's my Thin Manager, and what do I do from there? So Thin client then goes to the Thin Manager, which IP addresses are listed here, and then the Thin Manager server says, oh, you're this machine on boiler 1, you get these screens, you do this, away you go. And the advantage of this is, if this were to fail, we can put a brand new computer here, and literally within a few seconds punch in the IP address, punch in the primary and secondary, and the servers take care of all the rest. So this whole kind of setup here is also referred to as a thin client. So you'll hear the terms Arista and Hope, and really all of those in a roundabout way are basically the HMI human machine interface. Just a quick little overview of the actual panels themselves. You'll see a lot of Allen Bradley Rockwell Automation. Rockwell Automation is the company, the parent company, that owns a family of products that are named Allen Bradley. Allen Bradley used to be a company, Rockwell bought them out, and now Allen Bradley is a product family owned by Rockwell Automation. You'll see the Allen Bradley name, you'll see Rockwell Automation, they're one of the same, it's just a family. And this particular family of PLCs, or programmable logic controllers, is called the Compact Logic. It's just a family of PLCs. And PLCs consist of a processor, they consist of a power supply, and they consist of peripheral cards that do different things. So you have analog input cards that take a 4-to-20 signal from a field device and go into the PLC. They can also have 4-to-20 analog outputs that can control things like tell a valve what to do. And we have digital inputs that are switches for high limits, low limits, that kind of thing. We have digital outputs that are basically switches that can turn on a pump or a motor. So you'll also see the term CCS. That stands for Combustion Control System. That's what controls the air-to-fuel firing rate of the boiler. This actually runs the boiler. There's another system called BMS, which stands for Burner Management System. And that is strictly, it's a separate system altogether, and all that does is manage the safety of the burner. So that has limit switches, there's all kinds of devices that all have to be met in order for these, so these will all be cleaned up. I'm going to switch over here and we'll go over to the actual HMI, and we will go through here and give you kind of a basic tutorial of how do our screens work and what do they do. Alright, so let me just adjust the camera here just a little bit. So this is the screen navigation page. Think of this as like your home page. This is your starting point. This is where all things begin. So up here we have basically plant level screens, and we'll go in and just give you a little tour and walk through how some of these works. And then here we have CCS, that's combustion control for boiler 1. BMS, burner management system, that's for boiler 1, and CCS for number 2, and BMS for number 2. Now we have 3 panels here. Boiler 1 is over here. This is the BOP, or balance of plant, and we have another panel over here, which you can kind of see, which is boiler number 2. By design, we make one set of screens and we give them to all 3 of these HMIs. We do that for redundancy, so if for some reason this HMI were to be bad or to fail, we can go to any other boiler panel and get to the same screen and do the same things. And these screens will also be given to Cybertrol that they can put on a thin client, Arista, on a desktop type scenario for the control room or anyone in the Land O'Lakes network. So again, here's our screen navigation, here's our home page. You'll notice we have some heartbeats up here. We only have one set of heartbeats because this is our balance of plant. When this is successfully communicating between the thin client manager, which controls the graphics, and the Land O'Lakes a PLC network that the PLCs hook up to, that's when we get these heartbeats. And the heartbeats are basically just a keep alive signal, an indication that the Ethernet communications are working correctly. And again, we don't have boiler 1 or 2 fired up yet, so we don't have any heartbeats there. And just to show you really quick, our balance of plant panel does look a little different. We do have an Arista. We have an Arista PC with a Hope Industrial monitor. That goes to Ethernet, which goes to the thin manager server on the Land O'Lakes network. This is the thin client. Here we have another, move the camera here. Here we have another Compact Logix PLC, and this is configured a little bit different because the balance of plant has different field devices than boilers 1 and 2. We also have some Ethernet switches here that tie everything together. We're doing some feed water VFDs through Ethernet. And then this NAT-R is a device that acts as a bridge to go from a private local area network here via Ethernet to the Land O'Lakes corporate network there. So the inside of the BOP is a little bit different, and we do have, there's wiring diagrams that go into great detail as to how all the different slots, circuits, and cards, and what they do. So here we're back to our main page, and we'll just take a look at the plant master. And the and a lot of these are hopefully self-explanatory, where plant master is, okay, this is the lord over the steam plant. So here a plant master is basically the master firing rate that we tell the boilers to run off of. And then each boiler has their own submaster, so each boiler can run independently, or the plant master basically oversees those. Some more terminologies that you might see or not used to. SP stands for set point. PV stands for process variable. So you'll see those throughout different areas. And these particular little squares, we call those a Mike, what do we call each? I'm having a thought shower. These are faceplates. Faceplates is the name I was thinking of. Thank you, Mike. So we call these faceplates. So back in the old control world, you would have a physical controller that would do these same things. So we model that same kind of structure in our HMI design. So these, like I say, not all things are fired up, so we don't have a full display of things, but we can adjust our set points upper or lower, or button, you can key in a value. Again, we'll do more of this, but this is just a basic introduction. So to go back to my home page or my screen page, I go to screen selection, and now I'm back to the beginning. So here I go to plant overview, and this is kind of a 1,000-foot view of what's all going on in the boiler plant. So here we have meters, PA level, pressure, looking for more acronyms, FW speed water, let's see here, air dryer, steam flow, 1,000 pounds per hour, PCT percent. I know most of you probably know these by heart, but I like reviewing those for maybe some of the younger folks. So here's an overview of the plant. Go back to my screen selection. Here's our condensate level system. So this is a representation of our condensate tank, which is just over on the other side here. So this shows our level. GPM percent, CV is control valve, RO is reverse osmosis. Just looking for any other acronyms. Again, we have process variables, we have set points, and pretty much, you know, green is go, red is watch out, yellow is be add bias. Is our color scheme. And again, we don't have all this hooked up, so you might see some things that are a little bit out of the ordinary. All right, so go back to our home page, and here we have. Take a look at the deaerator. This shows the level as it goes up and down. Deaerator pressure. Pressure control valve is PCV. LCV is level control valve. There's our makeup water, plant feed water flow. And again, we have face plates for individual control of things, as well as information in a graphical user format. Here we have kind of a shortcut to the condensate level, because DA and condensate work closely together. We put a button so you don't have to go back to the start page. You just click over here and jump over to the condensate level. So we can kind of go back and forth between condensate and DA because they work well. They work hand in hand. All right, so we'll go back to here, and we'll go to feed water pressure. So here we have our feed water control valves, FCVs, plant feed water flow. Bearing temperatures have been removed because we're getting new pumps that don't require that. Here's our feed water pumps for the boilers. The recirc valves are something new that we're adding, and here's where you can start and stop pumps. Here's our pressure control, and again we have face plates for each feed water pump, and here's our lead pressure control face plate there. Alright, so let's go to the air compressor system. This is in the process of changing. At the time we designed this, there were 3 air compressors. Those have been replaced with air compressor 1 and 2, which are new, so these screens are going to change. But the air compressor system is basically just a window to what's going on with the air compressor system. Kind of same with the heat recovery. We'll be showing basically the operation of that. This is the 2-stage economizer that's up on the roof. And again, I'm going through this kind of quick, but again, this is just an introduction, just an overview, just a taste of how things work in an overview perspective. Now here we have combustion control for boiler 1, burner management for number 1, combustion control number 2, burner management number 2. So here we have just kind of a basic boiler overview, where this shows gas control valve, gas flow, feed water control valve, feed water pressure, drum level, just some basic, you know, here's what the boiler looks like. We've got some burner overviews where this shows when the burner is actually burning. I do believe we do have this kind of colored so that as the burner fires, it does animate. 1,000 standard cubic feet per hour. PCT is percent. Runtime. Natural gas, 1,000 standard cubic feet. Here's pressure the drum level to be process variable, that's where it actually is. And if we have a device that does control things, the output would be the feed water valve. Alright, back to screen selection, and let's see, we do have some P90 tunings that we can do, so we can kind of tweak the drum level. This is mainly for a technician to fine-tune the PID loops. Normal day-to-day operations, you should have the rest of this. Alright, and we'll just talk a little bit about the BMS. This basically says, okay, all my switches are set, I'm happy, I can run purge timer. Again, we'll go through this in more detail, and because we don't have everything hooked up, it's going to look a little thin. So stay tuned, more to follow. Here's we have purge submissions, submissives, permissives, those two. All right, and this just shows the status of the PLC for the burner management. Most of the time you may not need this, but if you're having trouble lighting off, you may need to go here to see a little more detail of what's going on with the system. And this just shows all the different cards within the BMS system. And again, we don't have anything hooked up yet, it's not powered up, so it's going to look kind of blank. Alright, and here we just have a little boilerplate overview. So this just shows new to the system is the economizer temperatures. Those are, and feed water flow. Those are new to boiler 3. We don't have this all hooked up yet, so that boiler 3 is up and running right now, but it's not connected to here. Alright, one last thing. You see a nice big button here, HMI shutdown. Don't let that scare you. What that does, if I push this, I get kind of a secondary warning. They're like, hey, you really sure you want to do this? And what this will do is this will basically shut down the software that's running on the Arista. It doesn't shut down the boiler plant. It doesn't shut down the PLCs. It just shuts down the screen, so that if we wanted to get to the just the root of the Arista computer or the Hope monitor, we would shut down the HMI software and go back to the basic computer level. And if you do shut this down, you can just restart the Arista machine. The Aristas are programmed to boot up, find the thin manager, get its screens, automatically fire up. No operator action required. So here we can go back and go previous screen. Here we're back to our home page. Alarms, more to come, and that's it for now. Hope this is helpful. Thank you.
Origato, Mike Nilis, Controls Ninja.